Yeah, this is another kind of problem when you consider a cantilever beam applied with a uniformly distributed load. So here the load W per unit length, which is applied up to a particular distance, that is A. So when the load is given like this, that is UDL is given like this up to a particular length A, or the over the entire length of the L, when you compare to the total length up to A length only, if the UDL is given. How to draw the shear force and bending moment diagram, that we try to understand here. And similarly here, initially we need to find out what is the shear force in between the various points. Here A and B are the two end points of the cantilever beam, and here I would like to consider another point C. Okay, so this is the another point up to which the UDL is acting. So I want to find out the shear force in between, first in between A and C. So I want to take A and C part here separately. So this is the UDL, this is A point and C point, and I want to consider a particular axis X at a distance small x. Okay, so the shear force at any section X is equal to what is the amount of the force up to a particular distance X it is acting, means that would be equal to W into X, which is the positive W into X, because it is acting in downward direction on right hand side. Okay, and similarly in between that we got in between A and C, the shear force is W into X. And similarly, if you want to find out the bending moment, so bending moment at X in between A and C. So what is the bending moment formula? Amount of minus amount of the force into the perpendicular distance, which is x by 2, that we know already. So it will become equal to minus wx square by 2. Okay, so here only we try to apply boundary conditions in between A and C. So for the same condition in between A and C, when it is x is equal to 0, the shear force at point, what is the point A? So that A is equal to what is the value W into 0, means it will become equal to 0. Next, similarly, when x is equal to A, that is the shear force at C is equal to, it would be equal to W into A. Okay, and similarly the bending moment when x is equal to 0, the bending moment at 0 means at A point, that is equal to W into 0 square by 2, means it will become equal to 0. And similarly when at x is equal to A, because in between A and C you are finding, so bending moment at C is equal to what you'll get, minus W into A square by 2. Okay, so these are the uh, four values which are used for drawing the shear force and bending moment. Later we draw that. Next, similarly we try to find out uh, shear force and bending moment. Shear force, that is here also shear force and bending moment in between A and C. Similarly shear force and bending moment in between B and C. Okay, so for that you try to take a reference of the cantilever. So up to a particular length the UDL is given. This is A, this is B, and this is C. Okay, we are trying to find out the shear force and bending moment in between B and C. So take one section here X at a particular distance small x you try to consider. Okay, so when you consider this section X, so what is the shear force with respect to the X axis? So it should be the sum of the forces which are acting on right side of this axis. So how many number of forces are acting? Only one force is acting, that is UDL. Okay, W per unit run or unit length. So the total force acting on right side will be equal to the shear force acting with respect to the x axis. So that could be equal to W into the length up to which it is acting. Yeah, because we need to consider the entire length, because we are taking the axis away from the UDL, not inside the UDL you are considering. So for that it will become equal to W into A. Okay. Similarly, for bending moment at x-axis, bending moment is equal to load into perpendicular distance. What is the load actually? Load is minus WA. Okay. And what would be the perpendicular distance? We know that the total distance is x. When you consider the C point for finding the bending moment for this UDL, what is the perpendicular distance means that we have already analyzed as half of the distance will be perpendicular distance. Okay, so with respect to x-axis, we need to find out the bending moment. So for this, the load is W into A. Then what it will become, the perpendicular distance means whatever this remaining distance plus half of this distance, or it can be x minus half of the distance. So you can write it as x minus what is the half of this one means x minus a by 2. X minus a by 2 will give you the bending moment equation. Okay, now we try to apply the boundary conditions in between B and C. So when x is equal to 0, not x is equal to 0 here, when you consider x is equal to A, because we need to get the shear force at point C. For getting the shear force at point C, consider x is equal to A. So when it is x is equal to A, the shear force at C point is equal to the same thing, you'll get WA only. Next, when x is equal to L, what is the shear force at B? That will be also same W into A. Why? Because there is no variable term is there in that. Okay, now. And similarly, when x is equal to A, what is the bending moment at C point? Minus W into A into X. In place of X, you need to write A minus A by 2. So it will give you A minus A by 2 means it will become again A by 2 minus WA square by 2 you will get. Okay, na? And now similarly, you go for finding the bending moment at another endpoint location. That means when X is equal to what it would be, X is equal to, for getting the bending moment at B, uh, x is equal to L. So when x is equal to L, so bending moment you will get at point B, that is equal to, in a formula, minus WA by 2 into place of x, you need to take L minus A by 2. L minus A by 2 you'll get. So what is the formula you'll get here? Minus WAL by 2 minus minus becomes plus, so plus WA square by 2. So this is the equation you'll get, but when you observe the equation, this equation is similar to the straight line. Okay, this will help you while drawing the shear force and bending moment diagram. Now we try to draw the shear force and bending moment diagram. So same beam representation I want to take. Let us take the black color. Okay, so cantilever beam that I'm considering here. So for the same thing, we can represent UDL up to A to C and B. Now I want to take some reference lines here. This is one reference line from one endpoint, another reference line from the endpoint, in between which we need to draw the shear force and bending moment diagrams. Here one horizontal and reference I'm considering for the shear force and bending moment. So in between A and C, we have already determined what are the shear forces at A and C. What is the shear force at A? 0. Locate one point here. So I want to take a different color here. Uh, Take orange color. So here one point at A shear force is 0, and shear force at C, that is WA, at any particular convenient height, locate WA, and these two should be joined with a straight line because the form of equation you got as mx, so which is the straight line equation. And now in between B and C, shear force in between B and C, when x is equal to A, that is WA same amount. When x is equal to L, again the same amount WA. So at the same height, locate the WA point and join these two, then we'll get the shear force diagram with a positive sign. Okay, now take another reference line for drawing the bending moment diagram. Okay, so for drawing the bending moment diagram, what is the bending moment at A? Bending moment at A, that is 0 only, locate the 0 here. And bending moment at C, that is minus WA square by 2, which is as a curve equation. So locate at any particular distance, that is WA square by 2, which is with a negative sign, and join these 2 points with a curved one. Okay, next bending moment at C, also at C, in the next case also we will be getting the same formula, minus WA square by 2, and try to identify what is the bending moment at B point, that is equal to WAL by 2 plus WA square by 2. So up to a convenient distance, with a convenient distance, locate the point on the reference line. Locate a point on the reference line which will be equal to this much value, and join these two with the help of what? With the help of uh, straight line. Why? Because the equation of form that you got here, that is mx plus c or mx minus c, that you can consider, which is the straight line equation. So these 2 points should be joined with a straight line. So this should be a curve and this should be a straight line. So this will give us bending moment diagram, and this should be curve and this should be straight line. Okay, inclined straight line with the negative sign. Okay, this is the way of drawing the shear force and bending moment diagram when the load that UDL is given up to particular length, that is A, as compared to the total length of the beam. So I hope you understood this to this case, and if you still have any doubts, please feel free to give a comment to my video, and in the next video I'll try to explain one example problem, then you can understand easily so how to draw the shear force and bending moment diagram. And once again, thanks for watching my video. Thank you all. And if you have not subscribed yet, please subscribe to my channel for more videos related to mechanical engineering subjects. Once again, thank you all.